Good evening, and welcome to the Science Frontier Network, where we explore discoveries that change our understanding of Earth's past and our future. Today, we are investigating a groundbreaking study that reveals the Sahara Arabian Desert, now one of the driest regions on the planet, was once an oasis of rivers, lakes, and thriving wildlife. And the proof? It's been hiding away for 8 million years in Saudi Arabian caves. To break down this complex science behind the discovery, I am joined by a climate specialist and historical analyst. Now, for the team behind the research.
This research was done by an international team led by the Max Planck Institute for Chemistry in Mainz, who worked with the Saudi Heritage Commission and the Saudi Ministry of Culture. Their focus was on a cluster of 7 caves located in the Duhul al-Saman region, northeast of Riyadh. And inside those caves, they found speleothems, cave minerals like stalactites and stalagmites. Now here's what's so interesting. Speleothems only form when water is dripping into a cave over long periods of time.
So, even just the appearance of these formations already tells us that the climate must have been radically different?
Exactly. So when the team found them, and they found a lot of them, it meant that the region had experienced continuous rainfall, not just once, but repeatedly over millions of years. But to accurately figure out when these wet periods had happened, the researchers used radiometric dating, analyzing the uranium isotopes inside the speleotherms. This allowed them to map out 3 major phases of rain, which include the late Miocene, around 8 million years ago, the early Pliocene, around 3 million years ago, and the middle Pleistocene, around 700,000 years ago to 300,000 years ago.
That's incredible. So, the case tells us that the climate was completely different. But climate alone doesn't paint the full picture. So, what did the team find within the fossil records that reveals the potential world that was once there?
So the team found fossils of crocodiles, hippopotamus, and elephants, animals that all depend on a constant supply of water. So when the team put all this evidence together, it became clear that this wasn't just a slightly wetter desert, but instead a thriving habitat, a place with wetlands, grasslands, and enough water to support entire ecosystems. These wet periods created what the researchers call green corridors, which are long stretches of vegetation and water that connect Africa to Eurasia. And during these humid windows, early humans and animals could travel across them. Without these pathways created by certain climate, human migration might have happened in a completely different way.
That's amazing. It's crazy to imagine that a place we now know as dry and unforgiving was once a highway for wildlife and the migration path for early humans. But of course, this green world didn't last forever. So, what caused this transformation back into the desert that we see today?
All right, this is where the story shifts dramatically. Around 700,000 years ago, Earth entered what scientists call the mid-Pleistocene transition. Temperatures in the northern hemisphere began to cool, and that cooling pushed the monsoon systems farther south. And when the monsoons moved, the rainfall that once fed the Sahara Arabian landscape of rivers and lakes began to fade. But here's the important part. Understanding why this happened helps scientists predict how modern climate change might shift rainfall patterns today. By studying historic climate cycles, researchers can better understand which deserts might become green again, which fertile landscapes might dry out, and how ecosystems change as global temperatures rise. It's like reading Earth's climate history, written in minerals, fossils, and stone.
A desert with a rainy past, and a future still unfolding. What may look barren today has shaped the journey of our species and may continue to do so as the Earth's climate evolves. Thank you for joining us on the Science Frontier Network. We'll see you next time.